All right, what about the remainder and some factor theorems that we're going to talk about? If f of x is divided by x minus k, where k is some number, then the remainder is the same as f of k. That sounds a lot more complicated than it is. If f of k equals 0, then that is a factor because we have 0 as no remainder. Okay? And so that also tells me that one of the points is k, comma 0. That's what our factor theorem states. Okay, so let's put that into action to actually know what we're talking about here. Use the remainder theorem to evaluate 4x squared minus 10x minus 21 when x equals 5. So the remainder theorem states that I can put that number on the outside of synthetic division. I can line up my numbers like I did in the last video. And then I can divide. So bring the 4 down, multiply the outside, put the answer right here, add straight down, repeat, and then add straight down. Remainder theorem says this number right here is the exact same number as if I do 4 times 5 squared minus 10 times 5 minus 21. Okay, so what did I do there? I took the formula and plugged it in. I also get 29. This particular problem's not too bad to do mental math. So 5 squared is 25, times 4 is 100, minus 50, and then minus 21. Not too bad. But sometimes those numbers are really large and things that like I would instantly type in a calculator. I'm not going to do in my own head, especially if I'm cubing something or taking it to the 4th power. Whereas a lot of times with the remainder, or like doing synthetic division, you don't typically need a calculator. Sometimes your numbers get big enough that you need a calculator, but most of the time they do not. So the point being here is that the point on the graph is 5, 29. And I did it 2 different ways. So way 1, that's with the remainder theorem like it asked. This is what you always did in all your other algebra classes to evaluate, right? Okay. We're still dividing. Different question, still dividing. Is x plus 3 a factor of this polynomial? I'm not going to read it out. So you could take a guess if you wanted. Or, yay, synthetic division. We're going to take these numbers. So 3, 4, negative 18, and negative 3. And the number we're going to put on the outside is actually a 0. So what plus 3 is 0? That's negative 3. Bring the first number down, multiply, add straight down, multiply, add straight down, multiply, add straight down. So again, if you are still slow to synthetic division, rewind it, watch it again, whatever you need to do. We bring down the first term, we multiply, and then we put that answer there, add straight down. Then we repeat, okay? All right, now to answer our question, is it a factor? It is not, since the remainder is not 0. Simple as that. Okay? All right, still dividing, but now we are doing something different. It says verify. So if it says verify, that means whatever we're doing is already true. Okay, that x plus 2 and x minus 2 are factors. Factors, remainder is 0. Okay, and then we're going to find all of the zeros of f. Okay, so if I start with x plus 3, that means I'm going to put a negative 3 on the outside. Okay. Oh, why am I putting these x's? I'm sitting here thinking about the next thing I'm going to tell you guys. That's why. All right. So then I'm going to bring my number straight down, multiply, add, multiply, add, multiply, add. Yay, I got a remainder of 0. Now, if I tell you that 3 and 4 are factors of 24, that also means that they're factors of 12, because 12 is a factor of 24. The same thing is true for something like this. I've already done division once. That must also be a factor to what is remaining. And so I'm going to divide again, and this time by 2. So I'm going to take the answer I had and divide it by 2. And yes, I got 0. Okay, I don't have to do it again because this was already a remainder. It was not part of the problem. And then I got 0. So now we had cubic. We had quadratic here. That means that this one is a linear, so I'm just dropping it down in degrees. X cubed, x squared, x. So this answer here is 3x minus 1. So the last part of this question says find all the zeros. Well, they gave us 2 of the zeros. Anything that gives us a remainder of 0 is a 0. And our last factor here, we're going to set equal to 0 and get 3x equals 1. So x equals 1/3. This is the part that really excites me and gets me, super nerdy. It's fine, I own it. These are the zeros. Here's what that means. That means that if I open Desmos and I type 3x cubed plus 2x squared minus 19x, oops, that's not 19, plus 6, again, not a 6. Look at my zeros. -3, 2, and then 0.3 repeating is 1/3. Okay, so remember, calculators have not been around forever. We used to have to do this by hand all the time. This is where this comes from. Okay, so we can find factors without a calculator. I believe in you. You can too. But this concludes most of the actual dividing. So stay tuned for the rational zeros theorem. We'll still be dividing though. Hate to break it to you.